under the assumptions, one to four. What are the four assumptions that we had? First, we went ahead and said that model is linear in parameters. Second, xi's are non-stochastic. Third, E of ui is 0. And fourth, xi's have a nature that not all xi's in a sample should be the same. Otherwise, they won't be able to explain any variation in yi. So, variance of xi is greater than 0. Under these four assumptions that we talked about, we can say that the OLS estimators are unbiased if assumption 1 to 4 hold true. Now, in order to understand what is unbiased, let us first kind of understand the mathematical formulation of being unbiased. So a model or any parameter is said to be unbiased if the expectational value of that parameter is equal to its true value. The expectation value of beta 2 hat is equal to its true value. What does this mean? This means that supposedly I take samples. So I take sample 1 and from there I derive some value of beta 2 hat. I take another sample. Let's say I take sample 2 and I derive another value of beta 2 hat. I take another sample, so sample 3 and another value of beta 2 hat. And I keep on doing this. I keep on taking the samples and I get different values of beta 2 hats. Each sample has a different value of beta 2 hat. But now supposedly we go ahead and we kind of go ahead and take average of these samples. Right? So I take out the value of beta 2 hat from sample 1, plus I take the value of beta 2 hat from sample 2, plus I take the value of beta 2 hat from sample 3, from sample 4, and so on. I find this average. Then the expected value that I'm getting of beta 2 hats, that is equal to the, or that's equal to the true value of beta 2 from the population. That is the meaning of being unbiased. So unbiased is you take so many samples, different samples, and as you keep on taking the expectational value of the betas of the samples, then it is equal to the beta 2 of the population. That is the meaning of being unbiased. Now, a lot of times students would get confused between unbiased and consistent. So we have to understand difference between unbiased and consistent. A parameter is said to be consistent if, as you keep on increasing the sample size of the same sample, then the newer and newer value that you get of beta 2 hat, that is closer to the beta 2 of the population. Just try and understand this. I took a sample 1, and from, supposedly my observations were 100. I found out a value of beta 2 hat. I kept these 100 observations as is, but I added another 100 observations to them. So now my sample consists of 200 observations. 100 were the earlier one and more 100 now. And again, I find out beta 2 hat. I again keep these 200 as is and I add another 100. So, now my sample consists of 300 observations. And I keep doing that. I add more 100 to it and so on. Then as the sample size keeps on increasing, this newer and newer beta 2 hat that you will keep on formulating, that will tend to the true value of the beta 2 from the population. If that is the case, then we say that beta 2 hat is consistent. So the definition of consistency is that limit of beta 2 hat as n tends to infinity, as the sample size keeps on increasing, the value of beta 2 hat approaches the true value of the population. If that is the case, then this is called a consistent parameter. So consistency is you take one sample and keep increasing the size of that sample, whereas unbiased is when you keep on increasing the when you keep on taking different samples and you average those values out and you get that equal to the true value of the population. So that's the difference between unbiased and consistent.